In this video, we're going to use the ratio test to determine the interval of convergence for the Taylor series 1 over 1 minus x. And the nth degree Taylor polynomial for this function is k equals 0 to n of x to the k. So it's Taylor series. Let's go ahead and we can use n or whichever letter we want. N to infinity of x to the n. So here's what we're going to apply the ratio test to. So the ratio test, we get the limit as n goes to infinity of the absolute value of a sub n plus 1 divided by a sub n. So x to the n plus 1 over x to the n. This one actually simplifies quite easily because what we end up with is the limit as n goes to infinity of just x, the absolute value of x, which is just the absolute value of x. So we get that the absolute value of x must be less than 1. Now what we'll do in this case is now test the endpoints to see what our interval of convergence is, because right now what we know is that x has to be in between -1 and 1, but because the ratio test is inconclusive when x equals 1, those must be tested separately. So if x equals -1, then our series becomes n equals 0 to infinity of -1 to the n, which is a series that just bounces back and forth between 1 and -1. And so the limit as n goes to infinity of -1 to the n does not equal 0. Therefore, it's divergent by the divergence test, so we do not want to include -1. If x equals +1, we get the summation from n equals 0 to infinity of 1 to the n, which is a summation at n equals 0 to infinity of just 1. We can actually use the same exact argument. The limit as n goes to infinity of 1 does not equal 0, so it's again divergent by the divergence test. So our interval of convergence is -1 to 1, not including either endpoint. So our interval of convergence, if we want to write in interval notation, -1 to 1.